So the agenda is really simple. I just got 3 points and a couple of slides, and hopefully it should be interesting for you all. So I'll talk a little bit about ecosystems and directions, where we're going. I'll share some perspectives about where this whole technology is heading. And I'll also share a little bit about looking ahead. What can we expect? How do we want to look at it? How do we want to address it? Okay, ecosystem. Put some very simple English words out here, and I'm sure, is anybody in this room not agreeing with any of these things? You can probably ask that in the question session, but more and more, like we had the teacher saying that I know where you are, what you're doing, how many days you were there, why you took a leave. Things are becoming real time. Okay, we are not waiting for a delayed response. We want faster responses, which is acceptable, which is fine. You want to be known where you are. Okay, in Bangalore traffic, you want to know if you got a meeting, are you stuck 50% of the way, 20% of the way, will I reach the destination today, tomorrow, whatever it is, okay? Or should I cancel the meeting? You know, you need to have insights. Many of us who work in corporate enterprises, we constantly have the battle of open source versus proprietary. Because again, there's sometimes a good answer, sometimes there's not so good an answer. However, both are solid proponents, both are usable technologies, but you sometimes have use cases more for open source, sometimes more for proprietary. In some cases, the open source is far better. I mean, in most of the cases, open source is far better because you have more collective minds, people willing to share knowledge, which helps you to build better and better things. The key with open source is you also have to contribute back. When it goes to proprietary, it goes inside, and you can't share it out, okay? So, again, there's no right and wrong. It's just that both are tangents. Sometimes you have to decide which tangent you want to bank on and take it up. Privacy and ethics, it's a raging topic. People who read the news see it every day. We have data breaches, we have issues of this nature going on. How do you address these topics, complex topics? Privacy is a complex topic, ethics is a complex topic. Is there a right answer to many of these things? May not be, it's a gray area in some cases. In some cases of privacy, there are going to be hard policies, I'm sure, which will start coming out, policy frameworks which are coming out. Large-scale use cases. Most of you who work in enterprises, do you work with a small data set anymore? 99% of you would be going to your IT head or the infrastructure person and saying, I want a Ferrari with X, Y, Z, this, that. You know, you never go and say, can you give me a small space? Never. Maybe at the college level, school level, when you do projects, yes, but even that's changing. If you look at some of the projects that many of the students do in the live enterprises for their projects, they work with large amounts of data. Plus, the data platforms, the open data platforms that are available also are sharing all this information with you. So again, that's a very, very important aspect to keep in mind. So how do you deal with large use cases? One is the data size, which is of course something you have to keep in mind. And secondly, the complexity of the models and the capabilities you're building. Both of these require a mindset, both on the architecture side, thinking about it. So you don't generally start a project just randomly or do something, I got a brilliant idea, I'm just going to do it, give me a box, give it. You need to do some thinking about it. Pushing the boundary. Traditional platforms and approaches looked at a lot of pre-processing, a lot of batch processing, a lot of data that was created, stored somewhere, post which you start figuring out, I want to do X, Y, Z, so on. Most of the situations that we face today is you have all this, but the boundaries are getting pushed. In some cases, I need to have real insights. I mean, if the school can do it, why can't an enterprise? Is that the right thing to do? May not be, but at the same time, the boundary is getting pushed. Okay, how much of information do I share? How do I share the information? How do two systems in a complex enterprise talk to each other? That's called pushing the boundary. Again, I'm pretty sure all of you have heard of these things, but I put it in some particular sequence which is familiar, which I'm used to. Let's go to the next slide. Okay, I'm not going to talk too much about each of these platforms, but these are some of the popular platforms that I'm sure most of you are using. I think these are brilliant platforms that are available today. which are making us work in a very good fashion in building fantastic models. Okay, I must say that I didn't want to put too much in there and make it look crowded, but I think these are some of the popular ones people use. I've been particularly fascinated with Julia, and I was pleasantly surprised there's a Julia workshop that happened today. It's a fantastic capability that's coming up. I particularly used to like Veka a little while back. I'm not sure how many of you use Veka, but it's a fantastic tool set, fantastic algorithms, and the beauty is all this is open. So if you wanted to actually work with traditional languages like Java and still build machine learning capabilities, Veka is a fantastic framework. R, of course, is one of those, again, one of my personal favorites. Those of you who've used it extensively and continue to use it extensively is a phenomenal library. I mean, I've not found a topic where they don't have packages and libraries that you can use. They've also taken radical steps in terms of how it can be productionized and so on, which again, you're familiar with some of the new platforms which support R from a commercial enterprise standpoint. So what does this mean? A couple of years back, few of us who used to like these platforms used to do it out of a hobby, maybe as an innovation. Today, it's no longer an innovation or a hobby. It's something that's part of your toolkit. But still, if you reflect on the previous slide and you're pushing the boundary, how do I make it into an architectural framework? Requires a thought. Okay. Notebooks are getting popular. Most of us were familiar with physical notebooks. Now, of course, we have got analytical notebooks. Jupyter, of course, many of you are using it. Fantastic libraries like the Python libraries that I've listed out here are really good. There were some really nice workshops on TensorFlow which were there, which again is amazing because these are platforms which are open and they give you enormous access to source code, which means that one, you can use a standard source code, plus you can enhance, take it to next level. For those of you who have the passion to expand on the source code, it may be good to participate in some of these open source projects and so on. Okay, anything else interesting? H2O has started picking up quite a lot of popularity. So let me go ahead. The slide looks very simple. Okay, but again, it took me a little while and I wanted to focus on this because this is what we're talking about last couple of days. We had one speaker who said yesterday that a neural network is not a black box. Then we had a couple of sessions of people talking about reinforcement learnings. Okay, so what used to be traditional textbook knowledge and what we used to do in education is now coming into the forefront. Now, in fact, the robot example that you saw in the video is also something that's going to happen very soon. Okay, depends when, but it will happen soon. So basically, in all modeling, there are two things. One is an input, and then some kind of a specific output that you want. But inside the processing, I've tried to make life really simple. I'm saying there is a model that gets created, and the model has to have certain outputs that are relevant. I've chosen these words carefully because they're not mathematical terms, but they're relevant terms. Every model that gives an output has to be repeatable. What does that mean? If I gave a certain set of inputs and the model was supposed to predict a certain behavior, most of the time it has to give me back that same behavior. Okay? Unless and until there was a pattern that was new for the model and it learned it and maybe it made an error, that could happen. But predominantly, the models have to be repeatable. Why is that important? Because in commercial applications, whether it be a financial, non-financial, whatever application, some human being's life is dependent on the output. So that output had better be accurate as much as possible, and it should be repeatable so that when you give this, that should be the output. Should I walk straight? Should I walk right? There's an obstruction. I need to go right. Left-hand side's a building. So if there was an error, that's okay. Then the model made it. But predominantly, it has to give me the right way to go. Trustworthy. It sounds very unmathematical in this gathering. But what I'm trying to drive at is more and more of the models we are building have a shade of gray. Is a customer happy? Maybe you can detect by the smile of the person's face or by the comments that the person has given. But how do you try to bring some kind of a mathematical nature to that output that's given? Sentiment analysis. How do you know that the sentiment is accurate? Okay, these are some hard questions that you'll have to think about when you start building models. The third topic, ethical, again, it's a very difficult topic, but let's say you're building a certain model. How do you ensure that the model is not building a bias, a purposeful bias? Okay? Accidental bias is okay, but one is you have to detect it. But how do you avoid a purposeful bias? So you need to start thinking about certain of these aspects when you build complex models. What might happen is, let's say, generally most of you, when you deal with unsupervised learning, you take all the data, put it inside, you do some kind of a k-means cluster or any clustering algorithm. And then we all think, brilliant, I've got a nice, cluster, there are some very minimal overlaps. But don't leave it just at that. Please try to understand what these clusters mean. Are you introducing a bias by force, or is there some kind of a unexpected outcome? So there have been some instances in my past when I had worked on unsupervised algorithms and the output didn't make sense to me. So there was a lot of dialogue between me and the domain specialist to understand, why am I getting this behavior? Is it a pure mathematical behavior? Or is there a bias? Or is there something that I need to do to unravel these cluster patterns? Okay. So in a broad sense, what I'm trying to say is the output, you need to have these 3 points of view also factored. Okay. Let's go to the one which is a model layer. Now the models are interestingly also becoming 2 types. One is there are use cases where I want to have a batch-based model. Nothing wrong with it. It doesn't mean everything has to be real-time. There are batch-based models. The other type of model, which increasingly everybody wants, is real-time. I want my super engine to compute what happened. How is X as a customer? I want to know his X second state of mind, or whatever that algorithm needs to do. So your models can actually take 2 forms. One is a pure snapshot-based model, and the other one, I've used the word reinforcement, but it can always be always learning. It need not just be reinforcement, but I just use that as a broader term. Okay? So these are the 2 broad cases of modeling that you need to think about. So the critical point over here is, as simple as it sounds, every day we do these kind of activities, but just pay a little more attention in how you use the algorithm, what kind of algorithms you use, what's the kind of data that is coming out, what are the data representations, what are the biases, and so on. Okay. Again, a simple slide, but this is kind of where we are heading. You'll find that the first and the 4th rows are identical. Because what happens invariably in the work we do is you can have a human being, you can have an application, and you can have a machine. Okay? I took the machine because there's a lot of IoT activity also happening. Okay? So the level 1 and the level 4 are identical, which means I can have a cross dialogue across these 2 layers. And what's the common part? I will have data. I might have multi-models. I might have a certain computation that is done, and I'm progressing more towards cognitive. What is the output of all these things? I need to know a context. I need to deliver a signal. Now, who consumes that signal? It again could be a human, application, or a machine. So, interestingly, what happens is, most of us in this room or this conference is predominantly focused on areas which are in level 2 and level 3. How do we build that effectively? How do I define a signal? I've used a signal as a generic term. It can be an insight, it can be a certain derivation, it can be a certain trigger, it can be an alert, and so on. A context. Context implies either it's a time-based context or it's a context very specific to that particular problem statement or the model that you're doing. So again, the combination of the last one, plus if I go deep inside to how the whole execution happens, these are 2 large areas that people need to start thinking about. Let me see. Okay, let's go. Now let me make it a little interesting. You see these pictures on the left-hand side. Okay. What I wanted to show was, as human beings are very evolved, all these pictures, they look nice. They're not done by a human artist. All these are graphics generated by an R program. Okay? They're fantastic perspective graphs that are run by an R program. On the right-hand side, what I've tried to do is, I uploaded these images into some very well-established cognitive platforms, and I tried to see what I tried to figure out. So the topmost picture says it's a star in the background, 0.6 confidence level. The one that is the most interesting one is the last one, which is, it looks like a cell to me, but the computer has picked it up and said it's a building, a close-up of a building, and with a confidence of 0.4. Okay, it does make sense that it's a 0.4 confidence, but the important thing is the human mind or the human eye is able to actually say that you could have actually looked at it and said, this looks like a fractal image. This looks like an artistic image. Maybe the first looks like a star, but none of the others seem to be matching, what you wanted it to be. But this is where technology is today, and we need to improve it. How do we improve it is, again, the kind of algorithms, the kind of techniques, the kind of learning. Okay, again, you need to have a lot of corpus of intelligence that is built in. Okay, maybe the second one is still accurate because it says it's a close-up of a logo. It is possible. But this is the thing, okay? Now I'm going to take you to another very interesting slide. I have no political affinity. I just took it because it's a very interesting topic, okay? Fine. I don't know how many of you saw the photo on the top. I saw it in one of the newspapers, okay? And then these. So the gentleman on the top is not the gentleman whom we think it is, okay? It's just a normal person who seems to be having a lot of the characteristics, okay? Mathematical characteristics. 0.9 confidence score, okay? Take a look at the left-hand side. A man talking on a cell phone, confidence of 0.3, okay? Again, look at the tags. Person 0.9, man 0.9, outdoor 0.9, older 0.3. Okay? And of course, bottom right side, we got a good match, 0.99 and 0.94. We were just off by 0.05. Now compare this to the actual human capability. I mean, it's amazing that the human mind, fractions of second, you can probably decipher this in some very, very small amount of time. Now think about this. How can I make my algorithms identify such things? End of the day, what happens? You write a wonderful model, you take input parameters, whether it's a neural net or any of these things, you extract certain features, and then you go back and try to see if it matches some other pattern, and then you get these outputs. How do I train such complex cases? How can I make a robot? Let's say it's supposed to help, let's say, disable the person. How do I make it train? So these are the hard problems that we're doing. And the good news is, at least in the talk, we have had quite a few fantastic sessions on the different kinds of neural net strategies, reinforcement learnings. These are the pioneering technologies, along with computational power, that's going to be able to take us to these levels of actually making this happen. Okay, another very fascinating slide. I don't know how many of you have seen this famous note on the net. It's actually by DJ Patel, the first chief data scientist of US. It's a very classic, famous note where he talks about how to productionize and large-scale systems, okay, scaling. So again, I did the same simple experiment. What is this picture? And then what will the computer interpret from this picture, okay? So somewhere, if you can read it, what is required to cut the timeline to half? Again, the generation by the program, time live in S2, okay? Again, handwriting is tough. Handwriting recognition is a tough problem, okay? It's not been solved completely. It's going to take a while, but anyway, that's an example. Right-hand side again of the same text, 92% whiteboard, but actually it's not a whiteboard, it's a kind of a note, okay? 68% document, 68, so the numbers read. So overall, the program is trying to do a good job, but you see the deficiency level between a 60% and a 90% accuracy. Okay. The easier one on the left-hand side, we've shown a phone, 0.8 confidence, it's electronics, but it didn't say it's a mobile phone. Okay? Again, it's just that, how do I train? And every day we have new products. Every day we have new capabilities, technologies. Okay? Bare bones. Another interesting case of personality, if I take a text, and then I want to try to find out, there's some text that you're shrewd, skeptical, blah, blah, blah. You are likely to like musical movies, this, and so on. So this is another application of people reading up text, trying to understand who you are from a text, or if you give sufficient textual patterns of who you are, it can try to understand you better. Okay? Again, a complex problem, not necessarily tough, not easy to actually say. So there's also a lot of work going on. So when we talk about the future, it's cognitive technologies, these kind of hard models we're going to be building, which can be used in various cases, either for computer vision, either for textual. And these are all, again, you go back to my 4-layered architecture. These are all what is going to be sitting in the layer 2. So how we're going to build the layer 2, which is going to be working in a trustworthy, repeatable, and ethical manner, is going to start playing a big role. Okay. There's also a lot of talk about knowledge graph. I mean, for all of us who use platforms like Wikipedia and so on, these are amazing knowledge structures. How can I make that go to the next level? How can I do these linkages? It's getting there, but at the same time, these are the future directions of where, and these cases are not just only for public usages. It can also be used in enterprises. Knowledge inside enterprises is huge. Business, learning, I mean, the domain is very large. So how do I take these technologies? How do I use it? Okay, this is going to be a very interesting, this is my own creation. It's got my own perspectives. So you may agree, you may disagree, but it's just my perspectives. So this is a very simple graph I have done with this definition: narrow AI use cases, semi-automatic, autonomous, governing, control switch, autonomous. I will take 2 careers. Actually, the thing is getting cut, but there is a disruption and there is an evolution. Okay? These are what we are kind of doing today. I have not put all the use cases, but an indicative set of use cases. Okay? A lot of domain-specific work, location services, your Ubers, your Olas, all these things are helping transportation. Probably early-stage driverless car might happen somewhere in the Western world. Finance trade applications, there's a lot of work going on. Defense, cyber. Predominantly, we are doing a lot of, on the lower side of the graph, is the enabling technologies or enabling paradigms. Okay? Separation, what's above the line is potential use cases. What's below the line are supporting technologies or capabilities. Predominantly, we're still statistical ML. There is more supervised and unsupervised, but predominantly, we're still working a lot of it on supervised. As we go into the semi-autonomous, what it means is in certain specific use cases, I will not permit 100% automation, but a controlled, semi-controlled automation. There are some early stage work, which is like the cognitive services that some of the examples that I've shown you. There are some early stage discussions on AI policy. For those of you who came across this in 2016, the US president had actually drafted an AI policy, okay, which is first of its kind. But if you read it, it's very interesting. It's a fairly interesting read, okay. Policies and so on. Okay, good. Let's go a little more complicated now. The next set of major changes will actually happen when there are 3 things that need to happen. Governing principles, there's a control switch, and there is full automation. What do you mean by governing principles? Governing principles means you are going to permit AI to proliferate more and more into use cases. But I need to define hard definitions of what it is going to do and what it is not going to do. Okay. Now, what's going to facilitate these kind of things? There's going to be a lot of lifestyle level changes, career orientations. Okay. There's going to be increased phenomenal usages of deep learning, unsupervised reinforcement learnings. And what's it going to help? It's going to help in places like education, okay, Of course, you're going to have a lot of evolution in terms of cyber and security, which will always be very high. An increased usage in terms of health and medical. See, now the Fitbits and all the IoT-based healthcare is going quite a bit. All of you have your own Fitbit data or whatever tracking device that you use. Has it taken the level where it has started defining your lifestyle level changes that you need to make? Maybe to some extent, yes. But it's going to start taking a larger and larger portion. And its use cases beyond. Good. A couple of areas that's going to really make changes are the energy layers. So if you look at today, the batteries start getting like your Teslas of the world. They started working on really renewable energy and batteries. That will make a big change. Cognitive services, I believe, will start getting a lot more intelligent as our models and data start building. Okay, so hopefully we'll have much better accuracies and pinpoint precision than the examples that I showed you. Some complex use cases, again, transportation will definitely become the next level thing. Many of you are aware of some of the big initiatives that are going on in congested cities, and so on. Finance, trade, and so on. Okay, let me go a little bit to the more difficult part. Personal robots are long-term away. I'm not put a specific timeline, but these are the more and more complex cases. Quality of life related applications, really complex. I don't think you'll reach a point where you can let a program just simply define your quality of life yet, because again, you need data, you need models, you need sufficient compute and algorithms to work that way. Big changes that will make such impacts, in my belief, is quantum computing, and then model behavior, which is more human-like. Nanotechnology will play a major role. So this is a very quick perspective which I had about the landscape. Many of the discussions and topics we have covered touch many of these things at the foundation algorithm level, but I think this is a pretty good indicator of where we're going to be going. Important point to keep in mind, the bottom two layers, the policies, privacy frameworks, lifestyle and career orientations are going to play a big role, because as we progress into this, we are not really sure of the impacts it's going to have, but we just need to be cognizant about it, whether it's the individual, whether it's the organization. Okay, got about 3.5 minutes, so I'll take up a little bit about perspectives. So whatever we're doing today from an AI and ML and future direction perspective, there is one which is known to me today and where I'm really under a controlled and very safe environment. I know what I'm doing. This is my first category of perspective that I'm sharing across, okay? The second one, it starts getting grayer. There is an unknown, very futuristic use case I'm trying to take up today. But looks safe. I can touch it. I think I can do something with it. So many of us, the startups, many of the people are exploring these cases. The third one is the unknown, where you're doing a really, really, big bang, new innovation, new thing, and you're on your own, literally on your own. Because there are no, either on the technology side, you're on your own, or on the, framework side, policy side, you're on your own. But broadly, we are actually hitting these three kinds of use cases today. Okay? So that's all I had right now to talk to you, because I wanted to talk to it. I'd like to leave it open for questions so that I can take some more of your questions and so on.
I want to know what kind of other innovations are you involved in, including neural net technologies and stuff. So you've not highlighted anything about what, you've said that you're precisely looking at things which will happen, but you've not highlighted what kind of innovations are you personally involved in as a company?
Okay, thanks, that's a good question. There is a purposeful nature. I have not spoken anything about my company's specific innovations, because these are more proprietary in nature, and I'm not, I can't disclose them in a, I can't disclose these out. But just to give a point of view, every organization, including ours, we are adapting to the change of technology quite rapidly. So my own role is specifically oriented towards how to bring the latest technology whether it be through machine learning, through digitization strategies, how do I get it back into the enterprise? So on an official role, it's basically the hard work of you finding a nice technology and actually blending it back into the ecosystem and making it work. So this is something I cannot share too much about, but you can talk to me later and I can give you some broad direction. So apologies on that. So that's something I can't talk too much about. Yeah. Thank you.
Thank you so much.